Hello. Maybe we will wait a couple more minutes because I saw there's actually a lot of people sign up, but currently there's only like 22 of your. Yeah, maybe we just wait like 2 more minutes. So who haven't downloaded the material can scan the QR code and then download the student copy that will be using data. Okay, we shall begin. Are you able to hear me loud and clear? Just check. If yes, then maybe give it a thumbs up. Can you hear me? Can you hear me? Okay, thank you. Okay, just in case if you all haven't had the materials yet, yeah, just download the materials using this QR and then prepare calculator and periodic table beside you during the session. So let me do a quick introductions about myself. I'm Sheila, and I've been teaching chemistry for about 4 years, and it's really satisfying to see like how my students really enjoy studying or like learning about chemistry. Uh, yeah, after being taught by me. And some fun fact about myself: I love outdoors activity like cycling, hiking, and diving. Yeah, and a bit of introductions about OVERMUGGED. So currently we have 8 branches across Singapore. So you can see like it's really like quite well spread out across Singapore. And currently we have about 1,000+ students. And yeah, some results that OVERMUGGED have achieved is that 70% of OVERMUGGED students achieve distinctions at their national exams, and we really have a very supportive learning environment for all our students taught by uh, really experienced and supportive tutors. Next, these are just some resources that OVERMUGGED provide for our students, including like notes, mock exams, practical notes, and some cheat sheets, as well as after-class consultation. Okay, yeah, if you want to know more about our regular class timing, can go visit the websites or just scan these QR codes. So nothing too serious. Just if you are interested, these are some timings that you can possibly look at for different subjects. Okay, this one you all can find on the website, so I'll just flash through. Okay, so that's all for the introduction. And let's begin with the revision. Okay, sorry, give me a while. Okay, so in this revision worksheet or any handout, there's like a total of 20 questions, but I don't think we have time to finish all 20. So I will be going through some, which is the questions that I've highlighted in yellow later. And then for those questions that we didn't manage to go through, I will provide the answer key, which you all can download from the Google Drive. I haven't uploaded it yet. So yeah, I will be uploading after the sessions. And you all can refer to the answer keys. Okay, so let's begin. Okay, before I talked about moles, I just want to assure you all that I hope you all don't have that mental barrier that wow, shit, more calculation is really difficult, very mathy, and yeah, so don't have that mental barrier because it's really not that difficult. And if you have that mindset already, I think it's not very helpful. Yeah, so just attend this session if you are really lost in more concepts. Okay, just try your best to follow these sessions and hopefully you have much better understanding on more concept after these sessions. So I've tried to summarize whatever you need to know in this chapter in just 3 slides. So this is the first one. So when we look at more concepts, right, really whenever you don't know what to do, right, always try to convert to moles, which is, so I draw a crown over here. So this is the king of this chapter. If you don't know what to do, always try to convert to moles. So there are different ways that we can convert to moles depending on what the question's giving you. So for example, if the question gives you number of particles, right, you can convert it to moles by dividing these Avogadro constants. Some schools use 6.02, some schools use 6, but I think it doesn't matter. In this session, I will use 6.02 times 10 to the power of 23. So you can think of it as 1 dozen equals to 12. So 1 mole is simply just 6.02 times 10 to the power of 23. Okay? And usually how the question will test is they will give you, they'll ask you to calculate the different number of atoms, number of ions. So all these, they are type of particles. So particles, they are just a very generic term. A particles can be an atom. A particles can be an ion. A particles can be a compound or molecule. Okay, so whenever we say compound, right, we are really just looking at one element. So just like one circle. For ions, it will be the positive and it will be your cations and anions. Okay, I will elaborate more. Whereas for compound is compound. Okay, so for example, Na2SO4, right? This one, Na2SO4, is made up of 2 Na atoms. So there's 2 Na atoms. And it's also made up of 1, okay, no space. Move this a bit further. Okay, 1 sulfur atom and 4 oxygen atoms. So if let's say I have 1 mole of Na2SO4, it means that I have one of these whole thing. But in this whole thing, there's 2 Na, 1 S, and 4 oxygen. So since I have 2 Na atoms, so there's 2 moles of Na atoms, and if I want to convert it to number of particles, I just multiply by the Avogadro constants. Okay, seems like most of my slides is just 6 times 10 to the power 23. Okay, so let's just use 6 instead of 6.02. Okay, and for sulfur atoms, there's only 1. Okay, when we say cat ions is referring, in this case, to the Na plus. So this one, I need you all to like shift your perspective a bit. Instead of looking them as atoms, I can also see Na2SO4 as 2 Na plus and 1 SO4 2 minus. That's why for cat ions, I have to multiply by 2 over here. Whereas for anions, which is the sulfate ions, this is the cat ions, anions, there's only 1 mole. And then to convert it to number, I just multiply by the Avogadro constant. If your question just asks for generally ions, right, it will be including both cat ions and anions. So here I will be looking at the Na plus as well as the SO4 2 minus, because they are all ions, but Na plus is the cat ions, SO4 2 minus is the anions. And what is a compound? This whole thing is a compound. And I only have 1 mole of it. That's why I will only have 6 times 10 to the power, 6 times 10 to the power of 23 of the whole compound. Okay, so that's how we calculate the number of particles. Always convert it to moles first, and then see what is the type of particles that the question is asking for. So I have to be very clear. You need to know what is an atom, what is ions, what does it mean by a compound. Then the next way to convert it to number of moles would be mass. Let's say if the question gives you the mass, and you can easily convert it to number of moles by the MR. So maybe some of you are more familiar with this, the triangle. So the mass triangle would be mass divided by MR to convert it to number. And then, mass divided by MR equals the number of moles. And just some conversion to bear in mind. 1 kg equals 1,000 gram. So whenever you want to use this formula, make sure your mass is in gram. Then the second way to convert would be volume. So this one is really depending on what the question gives you. If the question gives you mass, right, then you will be using this method. If the question gives you volume for gas, then you will be using this. So for volume, it actually looks very similar like the mass triangle, which is instead of mass, I have volume over here. And then this will be mole. For gas, there will be no molar mass for gas. Gas would be just the molar volume, and it's always 24. That's why for gas, if the volume is the same, okay, same volume, it means that the number of mole is the same. Okay, so can you write this down? This one is a trick to answer question faster. So for gas, if they say same volume, it means that it will be the same number of moles. Because for all type of gases, the molar volume is always 24. So if this one is the same, no matter what gas is it, I always divide by 24. That's why I will always arrive at the same number of moles. Hence, for gas, same volume means same number of moles. Then the third way would be this one. If the question gives you concentration, and you want to convert it to number of moles, you just multiply by the volume. And the concentration triangle would be on top, would be the number of moles divided by volume to give you concentration. Okay. And I remember last time when I was a student, I find it a bit like I easy multiply by volume, divide by volume. So you can use the unit to help you. So you know that the unit for concentration is mole per dm cube. correct? And if you want to convert it to number of moles, you simply multiply by volume so that they cancel out. Then you can get number of moles. So if these methods, if the units method help you to remember better, then by all means. Or if some of you are more comfortable with the triangle, then you can stick to the triangle. Okay, so these are like the different tools we use to convert to number of moles. There is a mass triangle, there's a volume triangle, as well as concentration triangle. So yeah, you will need this to help us to answer the question later. Okay, so moving on. Okay, by the way, if you have any question, can just write it down in the chat. Later, if I have time, I will look at it and answer you. Or even like after our sessions, I can stay back to address your questions. Okay, so don't be shy. Okay, just ask. Okay, for the next part, we'll be filling in the numbers. 1 mole of hydrogen gas. And then they ask about, what is how many hydrogen molecules, how many atoms? So if the question is asking about number of particles, because there's like no units here, then you know already in your mind later, I will have to multiply by the Avogadro constant, which is a 6 times 10 to the power of 23. So 1 mole of hydrogen gas, hydrogen is a diatomic molecule. So all hydrogen gas that exists as 2 hydrogen atoms bonded together. So these, I have 1 mole of H2. Okay, so hydrogen molecules is also molecules means I have 2 non-metals atoms chemically combined. So in this case, it's referring to H2 also. And I will also have 1 mole of them. So number, I'll just take 1 times 6 times 10 to the power of 23. Next one, for hydrogen atoms, atoms only means 1 circle. So how many hydrogen atoms are there? So since I have 1 mole of H2, right? It means that I will have, okay, this one means I have like 1 H atoms times 2. So total, I will have 2 moles of hydrogen atom. And then to convert it to number, I just multiply by 6 times 10 to the power of 23. Okay, I will skip these 2. Next one, let's talk about the copper sulfate and water. So if I have 0.5 mole of copper sulfate with 5 H2O, okay, so this one means that the 5 here applies to, it's referring to there are 5 H2O molecules inside this entire thing. So when it comes to ions, I have 0.5 moles. This is made up of Cu2 plus and SO4 2 minus, as well as 5 H2O molecule. Okay, so I'll just write 5 times. Okay, how many moles of ions? Ions include both cation and anion. Okay, so the whole thing, I have 0.5 mole. So means in one unit of CuSO4, I will also have 0.5 mole of copper Cu2 plus and also 0.5 mole of sulfate. So in total, I will have 0.5 plus 0.5. So equals to 1 mole. Okay, in this case, we don't include H2O because H2O is a molecule, it's not an ions. Next one, number of moles of oxygen atom. So we are looking at how many O atoms are there. So in sulfate, we have 4 oxygen, and then we have 5 water, right? And then there's 1 oxygen in each H2O. Means that in here I will have 0.5 mole times 4 mole of, this will be the number of moles of oxygen in SO4. And then I also have this one plus another 0.5 moles. This one also plus another 0.5 moles. Yeah, and then the same thing. So total there's 1, 2, 3, 4, 5. So I can just times 5. Okay, and the number of moles would be, punch my calculator. Okay, 4.5. So the answer for this would be 4.5 moles of oxygen atom. Okay, why is it 0.5? Because at the start, I only have 0.5 moles of CuSO4.5H2O. Okay, so 1 mole of CuSO4.5H2O give me 4, 5, 6, 7, 8, 9 oxygen. So if I have 0.5 mole of this, it means that I will have 0.5 times 9 mole of oxygen atoms. Okay, so this is also very similar. So let's go to question 1. Okay, what is the total number of electrons and protons in 1 mole of hydrogen gas? So hydrogen gas is H2, which is made up of 2 hydrogen atoms. Okay, this is a hydrogen gas, and it's made up of 2 hydrogen atoms. So here we want to look at the number of moles of electrons and protons. So you have to ask yourself, in one hydrogen atom, how many protons are there? So how much does it weigh? Zena asked, which question are you referring to? Are you referring to the hydrogen gas or the question before this? Okay, so total we have, okay, I will come back to you later, okay? So now we have 2 hydrogen atoms. So for 1 hydrogen atom, we know that there is 1 proton because in your periodic table, the proton number is 1. And all atoms are electrically neutral, so number of protons must be the same as number of electrons. So 1 hydrogen atom will also have 1 electrons. But now since we have 2 hydrogen atoms, so the number of protons and number of electrons will times 2. Okay, so means total we have 4 moles because we have 1 mole of hydrogen gas, right? And 1 hydrogen atom have 1 protons. And now we have 2 hydrogen atoms. So total I will have 2 moles of protons and 2 moles of electrons. So it means in total, there will be 4 moles of protons plus electrons. And I convert it to the number I just multiply by 6 times 10 to the power of 23. And that will give us 2.4 times 10 to the power of 24. That's why the answer for this question would be D dot. So every time it's like asking hydrogen gas if they don't give you, just simply don't give you weight, concentration or whatever. The answer to CJ's question is no. You cannot just assume it's 1 mole. But because in this question, the question says it's 1 mole of hydrogen gas. Yeah. Yeah, if they never say 1 mole, right, they confirm will give you either the mass, the volume, or concentration to find what? To let you find number of moles. If not, there's no way for you to find. Okay, just to answer Zena's question very quickly. Okay, how to find the mass for this thing? Okay, so if you have to convert number of moles to mass, it will be the mass using the mass triangle. So mass divide by number of mR to give us number of moles. So in this case, to convert it to mass, you have to take the number of moles, which is 0.5, multiplied by the mR. And what is the mR for this whole thing? It will be, okay, refer to your periodic table. The mR for copper would be 64. Okay, so mR for copper would be 64 plus sulfur is 32. Oxygen would be 16 times 4 plus water total is 18 because 2 is high. 16 is for oxygen, 2 is for hydrogen, and then I have 5 water. So times 18. Okay, and I believe if you press your calculator, that would equate to 125 grams. Okay, for question 1, how do you know that 1 mole is H2? I thought mole is like the size of it. I don't understand your question. I thought mole is like the size. Okay, 6 times 10 to the power of 23, right? It's like the number, it's not the size. Okay, so it's like 1 dozen equals 12. So 1 mole equals to a very big number, which is 6 times 10 to the power of 23. So it's like number, it's not the size. It's like 1, 2, 3, 4. Then you count until 6 times 10 to the power of 23. Okay, I got a message from Alex. How would you know what an ion is in the compound? Okay. How would you know? Because by now you all have learned chemical bonding already, right? So for compound, it will always be okay, so for example, like aluminum oxide is always like the ions of the metal with the ions of the non-metal. So in this case, it will be Al3 plus and O2 minus. But there are also polyatomic ions like sulfate. So Al2S3. So, okay, did I answer your question? I guess it's just something that you have to know, like how to split the compound into ions and anions. But it's usually, you look at the metals, and then usually the rest is like the anions. So this one is like SO4 2 minus, but I have 3 of them. So like that now. And then I have 2 aluminium. Okay, another question. How come you didn't take the ions for 5H2O for previous question? Because H2O is not ions. H2O is a molecule. That's why I didn't include it over here. H2O is a molecule. Okay. I hope that clarifies. Let's move on to question 4. Okay, 24 grams of oxygen gas occupies the same volume as 18 grams of gas P. So same volume for gas, it means that they will be the same. They will have the number of moles will be the same. Okay, so now we have oxygen gas. Oxygen gas is a diatomic molecule, so there will be O2, and then we have gas P. So we know this one is 24 grams, and this one is 18 grams. And the question wants us to find what is the MR of gas P. Okay, so how do we even start doing this question, right? Let's go through the thought process. So since the question wants us to find MR, it means that the only place where MR appears in the formula would be your mass triangle, which is a mass divided by mole, then MR over here. Okay, if I want to find MR, it means that I must know the mass, I must know the number of moles, so that I can find MR. So now since mass is known, so not an issue. Now my question, our problem is, what would be the number of moles for gas P? And because the question says occupy the same volume as the oxygen gas, right? So means the number of moles here would be the same as the number of moles of gas P. So can we find the number of moles of oxygen gas? The answer is yes, because number of moles equals to mass divided by MR. And I know the MR for O2 would be 16 plus 16. Okay, so let's do the working. Number of moles of O2 would be the mass divided by the MR, which is 16 plus 16. That will give us 0.75. Okay, and this will gonna be the same for gas P. Number of moles of gas P would be 0.75 moles. So MR of gas P will be mass divided by mole, which is 18 divided by 0.75. Okay, so the answer would be 24. Okay, to answer CJ's question, how do you know that 1 mole of hydrogen is H2? Would I be right to think that 1 mole of oxygen is O2? Okay, I assume you are asking like, how do you know hydrogen is H2? So, okay, this one, you guys need to know all the diatomic molecules we have. Okay, when the question mentioned about hydrogen, oxygen, nitrogen, and all your group 17 elements, chlorine, fluorine, bromine, and iodine. Okay, all these, they are diatomic molecules. So what is diatomic molecule? Di means 2. Atoms, atomic means like atoms. So for this elements that exist as diatomic molecule naturally. So means if you see hydrogen gas or hydrogen molecule, it would mean H2O2, N2, Cl2, F2, Br2, I2. Okay, so this is like, you have to know. Okay, so what you can do is, I suggest you can like go and refer to your periodic table, and then, so periodic table will look something like this, right? So if you go and like circle out these few elements, it will be here, and then this part of the periodic table. So these are hydrogen here, nitrogen, oxygen, fluorine first. Okay, so these elements, they are diatomic. Got a question from John. How do you know if it's ions or molecule? Molecules are for non-metals. Ions is in a compound. Okay, so if you see like everything is non-metal, right? For example, like NH3, CH4. So nitrogen is non-metal, hydrogen is non-metal. So all these will be called a molecule. But if there is a metal inside, for example, like NaCl, Na is sodium, which is metal. So this would be a compound already. And then compound, I can always split it into the cations and anions. Okay, question 5, I will come back later. Okay, for question 6, how many grams of glucose? So I'm supposed to find the mass of glucose. And the question gives us MR, then give us concentration. Okay, don't know how to start. So first thing, try to find the number of moles. So you know MR, but to find number of moles from MR, we need to know the mass. But we are clueless, like we don't know what is the mass now. So this is not going to be helpful. And we know volume and we know concentration. So this is very helpful because we have the concentration triangle, right? Which is mole divided by volume would be the concentration. So if I know volume, if I know concentration, I can find number of moles. So let's do that first. Number of moles of glucose would be concentration multiplied by volume. Okay, but please remember to convert the volume to dm cube because the unit for concentration is mole per dm cube. So to convert cm cube to dm cube, be divided by 1000. And that will give us 0.02 mole. Okay, so can you all see the light? We know the number of moles. We know the MR. Okay, very easily find mass because mass divided by MR will give us number of moles. So if we know MR, we know mole, then we can find mass. So mass will just be 0.02 mole multiplied by the MR, which is 3.6 grams. So answer would be A. Okay, for the next part, okay, what I will focus on would be this one because I think atomic mass, this one molecular mass, this one you already know. Just add up their atomic mass to find the molecular mass and formula mass. So what is new is over here, the percentage mass of the elements would be the number of atoms multiplied by the atomic mass of the element divided by the total MR multiplied by 100%. Okay, so what do I mean by that? Okay, let's use an example to illustrate. So to find the percentage of carbon in 200 grams of ethanol, first we need to know the total MR. So the total MR, okay, the total mass, okay, which is the MR of the whole thing, it will be 12 times 2 plus 5 plus 16 plus 1. Which is 46. So if I want to find the percentage mass of carbon, MR of carbon is 12. So the percentage mass would be 12 divided by the 46 multiplied by 100%. And that would give us 42.2. Sorry, 52.2. 12. Okay, wait, my bad. We have 2 carbon inside, so it should be 12 plus 12. Can you remember to multiply by the number of the atoms of the element? So I have 2 carbon in ethanol, so the numerator should be 12 plus 12. Okay, then for hydrogen, I only have 1 hydrogen divided by the total MR, so 1 over 46 multiplied by 100%, that will give us 13.0%. Oxygen, I also only have 1 oxygen, so 16 divided by 46 multiplied by 100%. So that is 34.8. And if you want to find the mass of carbon, okay, we simply, instead of multiply by 100%, I just multiply by the actual mass. Okay, so this one would be 12 plus 12 over 46 multiplied by 200. So it's really like looking at the ratio like that. So this is what I have, the mass for carbon. This is the total mass. And then like out of 200, how much of it is the mass of carbon? So in this case, that will be 104. And then for hydrogen, it will be 1 divided by the total MR. Then you multiply by the actual mass, which is 200. So that will give us 4 point. Okay, wait. This one should be 6. Because I got 6 hydrogen. Wait, this one should be 6 also. Okay, so sorry, guys. 2C2H5OH, right? There is 5 hydrogen here, another 1 hydrogen here. So total there are 6 hydrogen. So it should be 6 over 46 multiplied by 200. So that is 26.1 gram. Okay, then same thing for oxygen. I have 1 oxygen and the atomic mass for oxygen will be 16 divided by 46 multiplied by 200. So that is 69.6. Yeah. Okay, so if you go and add them up, I think this one would be 199.7. Okay, by right, okay, it should be 200, but now why is it not 200? It's because there are some rounding error when we find the mass of hydrogen and oxygen, because it's not exactly 26.1. It's like 108 something. Okay, then this one total, it should be 100%. Okay, so you can see the total mass of all the elements added together should be the same as the total mass of the compound. For question 8, what is the relative atomic mass of X? Then the question tells us the percentage by mass of X. Okay, I think now, like during exam, you might not know, like, where do I start from? So try to link it to the formula that you know. So contains 39.5% of X by mass, right? So you know this is related to the percentage of X in H2X2O6. And you know how to find percentage mass? It would be the atomic mass of X. So atomic mass would be AR of X. And I have 2X, so times 2. Divide by the total. So total would be, I just write the MR of H2X2O6 multiplied by 100. Okay. So this helps to get you started, like how to solve this question. Okay, and let's substitute in this value. I know the percentage by mass of X is 39.5%. Okay, but we have a little bit of issue here because I do not know the atomic mass of X. And then if I break it down, the molecular mass of H2X2O6, right, it would be, hydrogen would be 2.0 plus the atomic mass of X times 2 plus 16 times 6. Okay, I mean, you can solve this, but it will be like very mathematically complicated. So instead of using this, I know that if 39.5% is made up of X, it means that the remaining is going to made up of H and O. All right, so 100 minus 39.5, that will be 60.5%. So this one will be the percentage by mass of hydrogen and oxygen. Okay, why do I want to do that? Let me show you. Because by doing this, it helps us to remove that unknown from the numerator. Because I know the mass of H and O. In this case, it would be 2.0 plus 16.0 times 6. Right? Divide by the total. So unfortunately, total, I still have this annoying unknown plus 16 times 6. Multiplied by 100%. But can you see? By now, you only need to rearrange the equation to solve for this atomic mass of X. Okay, then the rest is like mathematics already. I'm going to leave it to yourself. So if you go and solve it, the atomic mass of 1X, it should be 32.0. Answer will be B boy. Okay, but one thing to take note is remember to multiply by 2 for the atomic mass of X because I have 2X in H2X2O6. Okay, that's where the students usually tend to make careless mistakes. Okay, before we move on to the next question, I'm going to point you back to the method to find empirical formula over here. So in this table, the first one will always be the mass of sample or like the percentage mass of the elements. Then to convert it to number of moles, we simply divide by the relative atomic mass. And to convert to simplest ratio, I just divide by the smallest number. So since here is 2.17 versus 4.35, so I divide by the smallest one. It means that here I will divide by 2.17 This side also divide by 2.17. Okay, that's how I get 1 and 2. Okay, but then, yeah, so here the simplest ratio will just be 1 and 2. But let's say if you get 1.333, okay, this kind you cannot just round down to 1. You have to find the lowest common multiple. So for example, if you really get 1.333 and then 2, you have to make this whole number by multiply by 3, such that it will become 4. Then this one, you have to multiply by 3 also. So this one becomes 6. Okay, so if you get values like 1.333 or 1.66666, this one cannot round up or round down. But if you get 1.8, I don't think you get 1.8. Okay, maybe like 1.95. This one is okay to just round off to 2. Or you get like 2.02. This one can just round to 2. Okay, but 0.333, 0.666, this one too far off, or 0.5 also cannot. You have to find the lowest common multiple like this. So with that, question 9, what is the empirical formula of this oxide of lead? So this table is, okay, so to find empirical formula, we need to have this table, then we need to know the mass of lead and oxygen. Oops. Okay, need to know the mass. So what would be the mass of lead? We have to refer to this table. So mass of test tube plus lead would be 29.05. Then mass of test tube we know is 21.28. So mass of lead, it would be 29.05 minus 21.28. And that is 7.77. Okay, then how do we know mass of oxygen? From here. So this mass is made up of test tube plus oxide, which is oxygen, plus lead. Okay, so if I want to find the mass of just oxygen, I will have to take the total mass minus away the mass of test tube, minus away the mass of lead, which is 7.77. Right? Let me check minus 21. Yeah, 0.8. Okay, then the rest is just as per normal already. Okay. Are you able to do the rest yourself? So, number of moles, okay, atomic mass first. This one would be 207, 16. Number of mole, it would be taking the mass, 7.77, divided by the atomic mass. So here I will get 0.075. This one will be 0.8 divided by 16. Then to convert it to simplest ratio, I divide by the smallest number. So in this case, you compare 0.0375 and 0.05. 0.03 is smaller. So both sides, I divide by 0.0375. And this will give me 1.33333. So take note here, you cannot just round down to 1. So you have to do a lowest common factor. So by multiplying both sides by 3, so this one will be 3, this one will be 1.333 times 3 will be 4. Okay, so answer will be PB3 or 4. P dot. So let's go back to the question that we skipped just now. Question 5. Okay, so now we have 11 gram of M3O4. This total is 11 gram. And then how many moles of M is present? Okay, so total mass is 11, and I know M is 6.2 gram. Okay, so that means that the mass of oxygen, it will be 11 minus 6.2, which is 4.8 gram. Okay, why do I want to do that? Let me show you. Because if you want to find number of mole of M, right, there is no way for me to find straight away, because to find number of moles, I will need to find the mass divided by MR. But now I don't even know what is M. So, okay, although I know mass, but I have no idea what is MR, because I do not know what is M. Like, you don't know which element is it in your periodic table. So you cannot find mole also. So we have to start from oxygen, which is 4.8 gram. And then the number of moles of oxygen would be 4.8 divided by 16. So that will give us 0.3 mole. So here, I need you all to be able to see that the ratio between M and oxygen is 3. So if I have 3 mole of M, okay, M and oxygen, I will have 4 mole of oxygen. So meaning that if I have 0.3 mole of oxygen, right? So to find the number of moles of M, it would be 0.3 multiplied by 3/4. Okay, divide by 4 multiplied by 3. So 0.225 mole. Okay, so from here, I find the number of moles of M. And the closest answer would be 8. If round up, then it would be 0.23 mole. Okay. Is everything okay? If not, okay, drop it down in the group, in the message. Because I will move on. Question 11. Yeah, I have a question from Alex. Why isn't the MR of OX 0416 times 4K? I think you are referring to question 5. Okay, because the 4.8 gram is the mass of oxygen atom. So we say atom just means there's only one oxygen. Yeah, and when do we use the 4 is when we're looking at the ratio between M and O. Then we consider the 4. Yeah, I think this is the only time where you don't need to put the times 4 over here. But other than that, usually when we find the MR of the entire compound, you have to multiply by 4. Okay, because the mass over here is just the mass of oxygen atoms. That's why just divide by 16. instead of 16 times 4. Question. Okay, question 11. Okay, ether, ethane dioic acid, blah, blah, after purification, okay, a lot of story. But what is being tested here is when you see the X like this, right? The X here is referring, X is the mole ratio between COOH2 and H2O. Okay, it means that this is 1. Okay, there's an invisible 1 over here. And then for H2O, it will be X. So we have to find what is X in this compound. Okay, and the question further tells us that we have 5.67 grams of the hydrate. So this is the hydrate, the one with water inside. And then giving off 4.05 grams of the C anhydrous acid. What is the value of X? Okay, so here we know that if this is 4.505 means this one must be, because of conservation of mass, whenever there's reaction, the total mass of the reactant and the product should remain the same. So this is telling us that the mass of water is 1.62 gram. Okay, so if I want to find the ratio between the COOH2 and H2O, we will have to use the empirical formula method. Okay, so let's draw a table. Then the mass for this will be 1.62, 4.05. Okay, and I think y'all can continue to do the rest. Okay, did I just say DIY? Okay, basically find the simplest ratio between COOH2 and H2O. Then that will tell you what is X. Okay, so for me, I got the simplest ratio as 1:2. So this means that COOH2, there will be 2H2O. Okay, hence X equals to 2. In the interest of time, should I go through this? Okay. Okay, very quickly. So same thing. N here would be the mole ratio between your MgSO4 and H2O. So MgSO4, there is a 1, like invisible 1 over there. So this is 1. This is N. And I know that the mass of water is 12.6 gram. This is 12 gram. So you can either use the method that we use in question 11, meaning that you find MgSO4 and then H2O, then you put the mass of each as 12 gram and 12.6. Then you continue to do to find N. Or actually for this question, there's no need for you to do that because you can straight away find number of mole of MgSO4 and you can also find number of mole of H2O directly. Just take the mass, divide by the MR of MgSO4. Okay, this one would be 12.6 divided by 18. Okay, so here you will get 0.09968 mole. This would be 0.7 mole. So to find N, it's just a mole ratio. So take 0.0. This one should be in the numerator because I want to make MgSO4 to be 1. So MgSO4 number of moles should be in the denominator. 668. That will give us 7. Okay, so how come in this question, we can just find number of moles and don't need to do this table method? Actually, you can do the table method. Also, you will get the same answer. But the main difference here is because for question 12, we know the MR for both substance. Whereas for question 11 just now, actually I also know the MR. Yeah, then I think can also. So alternatively, which is also faster. Okay, let me try. Or you can also just find number of mole of COOH2. That is you know the mass, which is 4.05 divided by 12 plus 16 plus 16 plus 1 whole thing times 2, which is the total MR. Let me try. I'm curious whether it works. Should work. Okay, then we move on to find number of mole of H2O, which is 1.62 divided by 18. 0.09 mole. Oh, it works. So X would just be, this one should be in the denominator. Yeah. Oh, yeah. Okay, so both works because I know the MR of this thing. But let's say if I have some random elements which I don't know, like maybe like NH, right? Then if I don't know the atomic mass of this, means I will not be able to put a number in the denominator over here. Yeah, then I cannot use this method already. But since now I know exactly what is in there and I know the molecular mass, hence I can find the number of moles. Then it's just a mole ratio. So you can choose whichever method you think that which one you like more. Okay. I think question 12 part B and part C is quite straightforward. So I think you all can manage yourself. For question 13, okay, deduce the possible identity of element X. Usually for this type of question, like possible identity, right, is we need to know the question is actually asking for it to know the MR of Z, okay, atomic mass of Z. Because if you know the atomic mass, then you can just look at the periodic table, the mass, and then which elements does it correspond to. Okay, so I'll just go through the thought process for this question. So to find atomic mass, it means that I have to know the number of moles. Okay, let's see what the question gives us first. So I have ZF2, and this is 1.203 gram. And I know the mass of Z is 0.997 gram. So how do we move on from here? Mass. Okay, so we can't really move on because I know the mass of Z, but I want to find the atomic mass. So to find atomic mass, I need to know the number of moles, right? Because mass divided by mole is mR, like that. So if I know this and I want to find mR, I need to know number of moles also. But in this case, I do not know the number of moles. So how else can we find the number of moles? It would be from this part over here. So F2, the mass would be the total mass minus the mass of Z, which is 0.206 gram. Okay, and I can convert it to number of moles very easily. Number of mole of F, which is the mass. Okay, this is the part that you don't feel comfortable because the mass would just be the mass of one F atom. Okay, so I just divide by 19 instead of 19 times 2. Okay, because I'm finding number of moles of F, I'm not finding number of moles of F2. Okay, that's why it's just divide by 19. And this is 0.1042 mole. Okay, so this is good because I know that the mole ratio between Z and F is 1:2, right? In ZF2, I have 1 Z, 2 moles of F. So their relationship, the mole ratio is 1:2. If I know this is 0.10842 mole, this one would be 0.10842 divided by 2. So I know the number of moles of Z already, which is 0.010842 0.00521 mole. Okay, so if I know the number of mole of Z, I know the mass of Z, then I can find atomic mass of Z, which is just mass divided by mole. So 0.997 divided by number of moles, which is 184. So you can go and search your periodic table, the elements with atomic mass of 184 would be tungsten. Okay, next part. This would be the full story of solving a mole calculation question. So very systematic. The first step when we try to solve mole calculation question, always write out the balance equation first. because the balance equation will tell us the mole ratio between each substance. And usually the question will tell us the information on one of the reactants. Then usually they will ask you to find what is the mass, what is the volume of the other reactants. So the trick is over here. So always try to find number of moles using one of the triangle, step 2. So either if the question gives you mass, then you use the mass triangle. If the question gives you volume, then you use the volume triangle to find the number of moles. Then step 3, we will use the mole ratio to link it to the substance that the question wants us to find. So let's say if I find this 2 mole already, right? Then I use a mole ratio, 2:1. So I know, oh, CaCl2 is 1 mole. So that would be step 3. Use the mole ratio. And then step 4, you can find the number of moles of the unknown. And then to answer the question, you use one of the triangle to convert it back to either mass or volume. Okay, one thing to take note, if the question tells you the number of moles for both reactants, right, that is a hint for you to find the limiting reagent. Okay, if you know the number of moles of both reactants. If the question only tells you 1, then you can just simply assume that the one that they give is limiting. Okay, so calculations just follow from there. But if the question gives you 2, like the number of moles of both reactants, then you have to find who is limiting. Okay, and how to find limiting reagent, I will go through in question 16 and question 19. Okay, for question 14, what is the percentage yield when 30 grams of ammonia is produced? 30 kg of ammonia. So this is the actual mass of ammonia. Okay, this one I didn't go through in the table just now. So percentage yield would be actual mass divided by theoretical mass multiplied by 100%. Okay, and actual mass will always be smaller than theoretical one. And actual mass is always given by the question. There's no way that you can calculate actual mass. Theoretical mass is from calculation. Okay, this is what we can calculate. So let's start. It's produced from 30 kg of hydrogen. So I have 30 kg of this thing. So if I want to find percentage yield, I have to find the theoretical mass of NH3. Okay, someone is asking for question 13. Okay, can you do a screenshot maybe? 3, 2, 1. Okay, I hope you're done. So, okay, 30 grams of, okay, 30 kg, I lost my train of thought. Okay, so let's follow the step. Okay, step 1 is write balance equation, right? But in this case, the question have already given us, so we can skip that. Step 1 is done. Step 2, calculate the number of moles based on one of the triangle. So here we are given the mass of hydrogen. So step 2, we will use the mass triangle because we know the mass of hydrogen. So be 30, remember to convert it to gram. So 30,000 divided by the MR. Okay. Number of mole of hydrogen, H2, would be the mass divided by the MR. So MR of hydrogen, H2 is 2.0. So this will give us 15,000 mole. Okay, then step 3. We will try to use the mole ratio between, we want to find NH3, right? So we'll be looking at the H2 as well as NH3. And the mole ratio according to the equation is 3:2. So step 4, I can find the number of moles of the unknown already. So number of moles of N2 and NH3 would be 15,000 divided by 3 multiplied by 2 to find the number of moles of NH3. So this one is 10,000 mole. Okay, so to find percentage yield, I need to find theoretical mass. Means that I have to convert it to mass. So that is step 5, which is use one of the triangle to answer the question. So question here, we need to find theoretical mass. So mass of NH3, it will be the number of moles multiplied by the MR, okay, which is 17. For NH3. Okay, so this is the theoretical mass of MR, which is from our calculation. So once you find the theoretical mass, you can take the actual mass, which is 30 kg, convert it to gram first, divide by the theoretical mass that you have calculated over here, multiply by 100%, you will get the percentage yield. Okay, I'm going to move on. For the next question, I want to find the number of grams of ammonium nitrate. So means that I am finding the mass of ammonium nitrate. Okay, I'm just going to write the formula. Okay, and we are given 27 grams of water. So in your brain, you should have some like strategy already because you know the mass of this. So you can very easily convert it to number of moles. Okay, so this is the step 2 already. I'm just going to write down the thought process, okay, because we're running out of time. So step 2, convert it to number of moles. From mass to mole, you just divide by the MR of water, which is 18. And since now our goal is to find ammonium nitrate, right? So step 3, we'll be looking at the mole ratio between H2O and NH4NO3. And in this case, the mole ratio is 1:2. Okay, so this is step 3, the mole ratio. So step 4 is when you have to find the number of moles of NH4NO3, which is the number of moles of water from step 2 multiplied by the mole ratio. In this case, is half, right? Yes. Okay, or just divide by 2. Okay, this is from step 2, number of moles of H2O. Okay, then step 5, our end goal is the mass. So find mass of NH4NO3. So you will just take step 4 multiplied by the MR of NH4NO3. I hope I didn't make any careless mistake. Step 4. To find mass, I will take number of moles multiplied by the MR. Right. Okay, so If you work it out, it should be, answer should be B boy. Teacher, is it possible to have the PDF of the worksheet after the lesson? Okay, later I will flash a QR code and then you can scan and download the worksheet. Can you give me 5 seconds to screenshot question 14? Okay. Okay, here you go. Next question, when they say ammonium nitrate is impure, can we assume that the impurity isn't water? In this case, yes, because water is one of the product. So water shouldn't be the impurities. For question 16, I love this question. So question 16, it tells us we have 4 dm cube of nitric oxide and 3 dm cube of oxygen. What would be the volume of gas remaining in the vessel? So first thing, once you see you know the information of both reactants, right? First thing you tell yourself is to find the limiting reagent. Because you know about the number of moles of both reactants, so that is a big hint for you to find which one is in excess, which one is limiting. And in this case, I'm going to teach a trick because remember just now I say the number of moles for gas will be the same if the volume is the same because I'm always dividing by 24. So now instead of going one big round to find the number of moles of this and this, right? I can just directly use the volume ratio. Because to find number of moles, I divide by 24, correct? Then I get some moles. And if I do, and I get some moles. Yeah. Then if I have to find the number of moles of O2, I also divide by 24. Then I get some value for moles. So since both, both divided by 24, the ratio is going to be the same. The mole ratio is going to be the same as the volume ratio. So there is, for gas, if all the reactants, all the substance in the equation are gas, you can just work with volume ratio instead of mole ratio. Okay, so in this case, if I have 4 dm cube of NO, it means that volume of NO equals to 4 dm cube. So since I know the ratio between NO and O2 is 2:1, if I have 4 dm cube of this, it means that I only need 2 dm cube. This is the volume of O2 required for the reaction. Okay, then we compare these two values. This is how I find limiting reagent. This is what I need. I only need 2 dm cube, but I have 3 dm cube. So what does this mean? This means that I am not going to finish all 3 dm cube of oxygen. Means the one that I have, oxygen, is in excess. In other words, NO is limiting. Okay, so once you find who is the limiting reagent, right, for all subsequent calculations, only use the number of, only work with this value. This value. Okay, this one, you can ignore already because I cannot use 3DM cube because not all 3DM cube is going to react. So it will not be accurate if I use that value to find the number of moles of NO2 that is formed. Because out of the 3DM cube, only 2DM cube is used. 1DM cube is just in there, nothing happened to it. Okay, so means that yeah, I have 4DM cube of NO reacting. So the volume of NO2 that is produced would be 4DM cube. Okay, before DM cube because NO and NO2, the ratio is 1:1. Okay, so sorry guys, I'm going to overrun by 15 minutes. But if you all want to leave, okay, feel free. The recording should be available after the session. Or I'm not really sure, but it will be uploaded and distributed to y'all. Okay, so continue. So you know the mole ratio between NO and NO2 is 1:1. So if I have 4DM cube of this, it means that I will also have 4DM cube of NO2. So that's how I got the 4DM cube over here. Okay, so to answer the question, volume of gas remaining in the reacting vessel at the end of the reaction, it will be the volume of gas that is produced plus whatever volume of gas that is in excess. Remember just now we discussed that I have 3 dm cube of oxygen, but I only use 2 dm cube of O2. So means at the end of the reaction, I will still have 1 dm cube of oxygen that has nothing happened to it. Whereas for volume of gas produced, I have 4 dm cube of NO2. So at the end of the reaction, I will have a total volume of 5 dm cube. Okay, someone requested for question 15. Okay, you can take a screenshot for question 15. Sorry, I still don't get why we use 4 dm cube. Okay, you mean like why we don't use the 3 dm cube, is it? Okay, that is because you have 3 dm cube of oxygen, right? But then only 2 dm cube of them will react. That remaining 1 dm cube is in excess. Okay, maybe like I use a like super lame okay. So okay, assuming like this is like one circle is like 1 dm cube. Okay. And I have 4 dm cube of NO. So I have like 4 circles. Whereas for oxygen, I have 3 dm cube of them, right? Okay, according to this equation, the ratio between NO and O2 is 2:1. It means that I will need 2 of these to react with 1. That is how the reactions take place. I need 2 light blue to react with 1 dark blue. But now I only have 4 light blue, means that I can only react with 2 dark blue. So means this one is in excess because this guy over here got no light blue to react with already. Okay, so if you use the 3 dm cube over here, which is the volume of oxygen, it's not accurate because this guy doesn't participate in the reaction. It has no light blue to react with already. So means whatever the product is being formed, right, it is limited by this 4dm cube. Okay, hence we cannot use 3dm cube. We need to use 4dm cube to proceed with the calculations. So the ratio is not in terms of mass / number of particles. When you are working, when all the substance are volume, you can just directly use volume ratio. You don't need to convert to mole ratio, because to convert to mole ratio, everything you divide by 24. Divide the volume by 24, so the ratio is the same. But if that confuses you, you can convert to mole ratio. You will get the same answer. Okay, so if everything is volume, just use volume ratio. But if the question gives you mass, give you concentration, please convert to mole. Okay, cannot work with mass ratio. Mass ratio is different because every substance got different MR. Okay, for question 17, okay, I know that I have 25 cm cube and 2.5 mole per dm cube of KOH. And I've produced 0.05 mole of water. And what is the volume and concentration of sulfuric acid used? Okay, so this one slightly dangerous because the question is asking us to find the number of moles of sulfuric acid. So remember, if wherever the question, whenever you know like the number of moles of both reactants, right, that is a big hint for you to find limiting reagent. So we can just check first whether it's tally. So suppose that I have this amount of KOH, right? So the number of moles of KOH here would be, you take the volume multiplied by concentrations. This is 0.0625 mole. Okay, and since the mole ratio between KOH and water is 1:1, okay, 2:2, which means it's 1:1 lah. So means that the number of moles of H2O produced should also be 0.0625 mole. But the question told us that, I produce 0.05 moles. It doesn't tally. Okay, not equal. So this means that this means that the KOH must be in excess already. Because if I have used up all the KOH, right, I should get 0.0625 moles of water. But now I only got 0.05. This means that something is limiting my water from being produced. So this means that my sulfuric acid must be the limiting reagent. Okay. So essentially now we are just looking at the mole ratio between H2SO4 and water, which is 1:2. If this is 0.05 mole, this one must be 0.025 mole. So you have to choose the options that give us 0.025 mole. And the answer should be C. Only this is 0.025. Okay. Okay, I think question 18, I will skip question 18. Let me see question. Yeah, can do question 19 as our last question. Okay. is it possible to have the PDF of the worksheet? Okay, I think this poor girl asked me many times already. Let me just drop her the link. Okay, guys, I'm sending the link to the worksheet. Let me know if you cannot access, okay? This is the link to the worksheet. Sorry, could you go back to question 17 for 5 seconds? Okay, here you go. Okay, on the same link later, I will be uploading the answer key. Okay, guys, so don't leave the chat yet. Okay, question 19. Write a balanced chemical equation for the reaction. It burns with a blue flame in excess of, okay, so we have H2S reacting with O2 to form sulfur dioxide. So sulfur is S, di means like 2 oxygen. So sulfur dioxide will be SO2 plus water. Okay, then if you balance it, should be 2, 3, 2, 2. So step 1 is done. Given that I have 8.65 gram of H2S and 10,000 cm cube of oxygen, what is the volume? Okay, I want to find the volume of sulfur. Okay, so again, a big hint for you to find limiting reagent because you know the mass, you know the volume of both reactants. So means that you can find the number of moles very easily, right? You just divide by the MR. This one you can divide by 24. But remember, convert this to dm cube first. Then you can find number of moles. So if you know the number of moles of both reactant, please find limiting reagent. So I'll just go through, okay, let me just write down number of moles of H2S. I got, okay, I will skip some steps. You can calculate. I got 0.25441. And then number of mole of O2, I got 0.41667. So to find limiting reagent, you can use any, like start from any, like either H2S or O2 to find limiting reagent. So let's say you want to start from H2S. So means if I have H2S and O2, the mole ratio is 2:3. Okay, so now I have 0.25441 mole of H2S. So how much oxygen would it react with? So oxygen required would be 441 divided by 2 times 3, right? So this is 381615. Okay, so this is what I need. And this is what I have. So what I have is more than what I need. More than need. Means O2 is in excess. Okay, so if O2 is in excess, I shouldn't use this value for my subsequent calculation already. I should use this value. And what are we trying to find? We want to try and find sulfur dioxide. So once I've determined the limiting reagent, which is H2S, I will be using H2S and sulfur dioxide, and the mole ratio is 2:2, means 1:1. So that means that the number of moles of sulfur dioxide would be the same as H2S. Okay, then to answer the question, step 5, find the volume. So from number of moles to volume is just number of moles, okay, 0.25441 times 24. Okay, then you should get 6.11 dm cubed is the answer. Okay. Yeah, so this would be the last question that I want to go through. Yes. Before we end, can we like take a big a group photo? So if it's okay, can you like on your camera? Then I will take a screenshot. Okay, let's make this quick. Okay, I start to see a lot of people leaving. Okay, if not, I will just screenshot like that. Okay, for the next part, okay, if you all find this session helpful, yeah, feel free to scan this QR code and then write, yeah, leave a review for me. Yeah, I think it'd be very encouraging if like I know these sessions has helped you in understanding this chapter better. Okay, so can scan this QR code and then, yeah, any feedback about this session. Okay, then for the next part, okay, this QR code is for the materials that you have been asking for as well as the answer sheet that I will be uploading. Okay, let me upload it now. Okay, I've just uploaded the answer. Can you let me know like if you all can see? Wait, there's no QR code. You cannot see me. This is for the review. And then this QR code is for the material and the answer key. I've just uploaded it. So are you able to see the answer key already? Yes, no? Should have the answer key already, right? Okay. Thank you. Okay, those who still want to clarify question can, yeah, just unmute yourself and then I'll be able to help you. If not, the rest can, yeah, leave already. That's all for today. Thank you, guys. Good night. Write a review if you have any feedback for this session. Will the video recording be uploaded? Yes. Yes, the recording will be uploaded. And I able to take a pic of question 19. Sure, wait. Question 19. Okay. Okay, I will stop the recording here. Thank you guys. Good night.